Today let us discuss about the CTOD and PWST. This is a group discussion between the engineers. Mr. Tom, everyone keeps saying CTOD this and PWST that. What on earth are they talking about? Tom, Lisa, it's not as scary as it sounds. CTOD means crack tip opening displacement. It's about cracks opening up. Exactly, it's a clever test that tells us how tough our welded steel is. Basically, how much it can stretch at a crack before it gives up. Basically, how much it can stretch at a crack before it gives up. That's what we are going to find out. We use it to decide if we can skip post-welding treatment or PWST for short. PWST, that's a bit where you heat the weld again after it's done, right? Spot on. We do it to reduce stress and make the weld tougher. But sometimes if our CTOD test proves the metal's already tough enough, we can skip it. Saves time, money, and that one. Basically, we poke it, pull it, and if it doesn't crack, no need to bake it. So the testing begins. Alright folks, the project spec says CTOD testing must follow BS 7448 or ISO 15653. That sounds fancy. What do they mean? They are just the British and international rules on how to do the CTOD test properly. So they are going to explain us like how to do the CTOD test properly. And those are the rules, like a recipe book for metal testing. And we will need 3 valid samples, mind you, proper test pieces. 3 samples. Why 3? Because 1 might be dodgy, 2 might confuse us, but 3 gives us confidence. And that's a lot of work for a bit of metal. Not just a bit of metal, Dave, it's the thickest bit. We will never weld on this job. We test the biggest one, the worst case scenario. So if the thick one is fine, the rest would be 2. Exactly, a clever thing. The rules and numbers. And now the rules say at 0 degrees Celsius the CTOD must be at least 0.2 millimeters. Wait, 0 degrees? That's freezing. Why so cold? Because the steel can get brittle when it's too cold, especially out at sea. If it behaves well in the cold, we know it's strong. For materials, we tested 0.35 mm. For welding consumers, 0.25 mm. We need at least 0.35 mm for materials. For welding consumers, 0.25, and for WPS, that's the welding procedure, 0.2 mm. So bigger number means tougher metal. That's right, bigger metal means tougher metal. So it shows how much the crack tip can open before it fails. So it shows how much the crack tip can open up before it fails. As long as nobody tells me to measure 0.2 mm with my tape measure, I'm happy. So what about this PWST thing? When must we do it? We must do the PWST when we are welding tubulars with diameter to thickness ratio less than 20, or nodal joints thicker than 40, or any other parts thicker than 50. So basically it's chunky. It gets heated again. Correct, especially for non-TMC metals. TMCP, thermomechanical controlled process steel, strong stuff. It doesn't usually need the heat treatment of welding. If it's a special steel, then we check with the steel maker and company. Sometimes CTOD testing can replace PWST, but only if company approves it. In writing, mind you, always in writing. Also twist. Dave, what about when we are working offshore? Nobody's lugging a furnace onto the platform. Exactly, Dave. Offshore welding gets a pass. No PWST there. But you will need fast PQRs, WPS, new CTODs, every new project. Every single one. Safety never takes a holiday. Wrapping up. Right then, to sum it up, CTOD shows how tough our welds are. If CTOD values meet the limits, we might skip PWST. If it's thick, special, tricky steel, we may still heat it. And everything must be tested, witnessed, approved by company. And tested 0 degrees Celsius. That's literally cool. So what the CTOD actually measures is, let's start simple. When a crack starts in a weld, what do behaviors can the metal show? It can either stretch or blunt the crack tip. that's ductile. Snap suddenly, that's brittle, right? So exactly, the crack tip open displacement CTOD measures how much the crack mouth opens when it's just about to propagate. Which property does that represent? Fracture toughness. Which property does that represent? That's a fracture toughness. So under BS 7448 and ISO 15653, we record delta, the crack tip opening at a defined force or fracture. The higher delta, that means tougher the steel. And that's the number. Spec limits 0.2 mm minimum at 0 degrees Celsius unless drawing state otherwise. Why the test exists? Why don't we just rely on Charpy impact test? Because the Charpy only tells how much energy breaks a small notched bar. It does not simulate crack growth in a real structure. Correct. CTOD uses a fatigue pre-crack, so the crack tip has the same sharpness as a real defect. That's why 7BS74448 insists on pre-crack length between 0.45B 0.55B. And this spec also allows CTOD to justify skipping PTOD because it gives a direct evidence of fracture toughness after welding specimen. Now, what size type of specimens are used? Single edge notched bend. Single edge notched bend specimens usually be equal to W by 2 cut from the weld or heat affected zone. Good. Class of 5 covers geometry. Orientation must represent the most critical direction for welder pit. Usually notch in the heat affected zone or crack front parallel to the fusion line. And as for the project spec, 3 value specimens form a set Y3 to demonstrate repeatability statistics. One outliner can't represent the whole world. One outlier can't represent the whole world. Exactly. BS 7448 calls a test valid only if the crack extends within 10% 70% of the ligament of if the side grooves are within the tolerance. Material C control. Now the material choice. The spec says C not less than 0.02 below the project maximum. What C? So that's a carbon equivalent, a formula predicting hardenability. So good memory. And why that 0.02 below rule? Because we want to test the toughest to weld. We want to test the toughest to weld, most crack sensitive steel. If that passes CTOD, everything else with lower C is acceptable. So we want to test the toughest to weld and the most crack sensitive steel. The welding conditions for test plates. The class also says heat input a representative of the highest used in the production. Why not test the lowest? High heat input coarsens the heat affected zone and can reduce toughness. It's the worst case, right? And the heat input is calculated so it's regarding the PQR. So if we test it with the 2.5 kilojoule per mm and later at weld at 2.0, we are still safe. Exactly. Temperature and acceptance. Now, at what temperature are we required to test 0 degrees Celsius unless the design drawings specify otherwise? What's acceptance criteria? Least value of delta C, delta U, delta M should be greater than or equal to 0.2 mm. Can you remind me what those symbols mean? Delta C is that CTOD at onset of crack extension, CTOD maximum load at final fracture. According to BS 744 and XA, delta C is a preferred parameter because it corresponds to the initiation toughness. There are some additional stricter minimal criteria. Base metal should be greater than 0.35 mm. Consumable 0.25 WS. Why the difference? Because the base metal should have the inherently higher toughness. Base metal should have inherently higher toughness. Welding metal procedure are more variable. It ensures the weakest link still meets 0.2 mm. It ensures the weakest link still meets 0.1 mm. When the CTOD is test valid, if a crack with the outside 10%, 70% ligament, if the fracture does not pass through the notch, or if the clip gouge is not aligned, it's also invalidates it's also if the temperature deviates more than plus or minus 2 degrees and if force displacement is irregular 1.g thermocool or we do the latest quality data or nothing. What must CTOD report include? ISO, material identification, welding parameters, specimen notch location, pre-crack length, temperatures, delta CULE, force displacement for such and the format also wants CULE heat input. Periodicity when and why. Let's start with the post treatment. Why is periodicity applied? To relieve residual stress, temper mechanistic structures and restore toughness. For carbon magnet steel, the typical cycle is 580 degrees to 600 1 hour per 25 mm thickness, minimum 30 minutes holding. The requirement is period is mandatory for tubeless DBD less than 20, normal joints greater than 40, other joints greater than 50. Why do thicker or low DBD compounds need it? Because they restrain shrinkage, causing high residual stress and potential cracking if untempered. Periodicity assumptions on CTOD justification. When may we omit periodicity? If CTOD testing and fracture mechanics assessments prove well fracture toughness is sufficient and there are proofs in writing, exactly that's allowed mainly for TMCs. Last like qualified manufacturer. So CTOD plus FEMA replaces thermal relief with mechanical evidence. So offshore installations period is waived because heating is impractical. Instead, new PQ or new WPs are qualified with CTOD and process run. Those results feed into the FEMA, demonstrating safety margins against brittle fracture. So every offshore project must redo the CTOD testing even if we have done similar ones before. Yes, different joint details, different steels, new evidence required. Fracture mechanics assessment. Let's dig into that. What's the main equation used in FEMA? Usually failure criteria KI, delta equal delta. The stress intensity factor from applied load is compared to the critical toughness from CTOD. Engineers calculate the critical flaw size. It is how we prove existing defect won't propagate. Existing defects won't propagate. That's what causes fracture mechanics justification for periodicity exemption. Why does insist on government or government approved labs? Because such labs hold accreditation and all those things. Documentation package, final reflection, key takeaways. Number of specimens as per BS greater than 3. Temperature 0 degrees Celsius plus minus 2. Minimum delta 0.2 or greater. Base metal 0.35. CE for steel less than or equal to max CE, not less than it should be greater than 0.02. And periodicity DVD less than 20, thickness greater than 44, and all other parts greater than 50. PLC assumption, written consent only, approval on CTOD, FEMA, FMA, fracture mechanics assessment language area. Introduction to fundamental fracture mechanics. Before we touch a welding rod or open BSM, what's the first thing we ought to understand when we talk about CTOD testing? That is about the measuring how tough a weld is. Exactly, but it's not just tough in the casual sense. We measure fracture toughness, the resistance of material to a crack growth. Why do we care about the cracks at all? Because every weld's got a little flaws hiding in it somewhere. Even a perfect looking weld contains an inclusion porosity, tiny undercuts. Structural code assumes such imperfections exist. The trick is to make sure that they don't grow catastrophically when the structure's under load. That's where the fracture mechanics comes in. It lets us predict whether the given crack will stay dormant or race across the joint. So today's lecture begins at that foundation, how engineers describe and measure the behaviors of cracks. Only then we grasp why CTOD testing periods exist in the course. When we test steel in tension, what property do we usually quote? Yield strength or ultimate tensile strength? Correct. Those tell us how bulk materials behave, how much stress it carries before deforming or breaking, how much stress it carries. Do they tell us anything about the small crack or the toe of the weld? Not really. The stress near the crack tip is much higher than average stress. the crack acts like a magnifying glass of stress. Local intensity of stress at the tip is described by a parameter we call K, stress intensity factor. It depends on the road crack size geometry. When K reaches the critical value, a rapid fracture occurs. K reaches critical value. The critical value is what laboratory fracture toughness test measure. Yes, but in most roller structures, the material does not remain purely elastic up to failure. Plastic deformation occurs at the crack tip. That's why we move beyond KIC to elastic plastic concepts such as J integral or crack tip opening displacement.